Hello, now we have shifted to YouTube and let's start. Now I'm talking about neuromuscular junction. So as I told you before, the nerve is making an intimate contact with the muscle and this is happening at the neuromuscular junction. Okay, coming, as you all know, neuron. Neuron is a structural and functional unit of the nervous system. It has got soma, it has got axon. You look at the end of the axon. End of the axon, it loses its myelin sheath and it gives lot of branches called terminal branches. At the terminal branches, at the end of the terminal branches, we have got some swellings. Those swellings are known as synaptic knobs. Axon terminal is there and it has got a swelling below the axon terminal, that is called synaptic knob. So you concentrate on this axon terminals and the synaptic knob only. I'm not talking about the other part. Okay. Now look, now this nerve, where it is innervating the muscle, it has lost its myelin sheath. Myelin sheath is lost and we can see this terminals. These are called the nerve terminals and in the end they are called knobs. Those knobs are called the synaptic knobs or the end feet, or they are also called as terminal buttons. Anything means one and the same. These terminal buttons, you look at the terminal button, where is it making a contact with? It is making contact with the cytoplasm of the muscle, not with the cell membrane of the muscle. Continuation. Okay, right. So the synaptic, what did I say? These terminal buttons are making contact with the muscle. Where exactly? It is making contact with the cytoplasm of the muscle, not with the sarcolemma of the muscle. But if you can see it properly, it is making contact with the cytoplasm of the muscle fiber. This intimate and intensive contact of the terminal button with that of the muscle fiber, cytoplasm of the muscle fiber, muscle cytoplasm is called the motor end plate. And this motor end plate is where the all action is taking place. So each motor end plate will have one nerve fiber and this is present at the center of the muscle fiber. This junction is present at the center of the muscle fiber. So these terminal buttons are making contact with the cytoplasm of the muscle. That you should remember. That is called motor end plate. This is where the whole of the action is taking place. So motor end plate, here in this rectangle you can see a motor end plate. So here what are the other? Some myelinated axon is losing its myelin sheath. You can see that, and this nerve, plenty of nerve branches are there which has got swellings. They are called synaptic knobs. Okay, now this is only the terminal button or the synaptic knob or your end feet. They are all one and the same. We are only talking about the terminal button. If you look at this terminal button, you have to remember two names here. One is the presynaptic membrane. The yellow one is the presynaptic membrane. End of the nerve membrane is the presynaptic membrane. And the blue one is the postsynaptic membrane. And in between this yellow and blue is the synaptic cleft, where lot of ECF will be there in that synaptic cleft, which lot of ECF is there. Okay, now coming to this presynaptic membrane, you hear some names are very important. In examination point of view also, you should write few names. So as I told you here, motor end plate is one important name. Presynaptic membrane, postsynaptic membrane, synaptic cleft you should know. So look at this presynaptic membrane. We are talking about the terminal button. The end of the nerve membrane where it is making contact with the muscle membrane is the presynaptic membrane. and the muscle membrane is called the postsynaptic membrane. So in between these two membranes is the synaptic cleft where there is ECF in it. Okay. Now, and one more important thing you should remember here is the synaptic cleft will also have an enzyme called acetylcholinesterase. I'll tell its significance later. It has got acetylcholinesterase. This acetylcholinesterase is essential for the destruction of ACH. I'll tell you why the ACH should be destroyed, but you should remember it has got, synaptic cleft has got acetylcholinesterase. Now, coming to this synaptic, this terminal button, as you can all see, the terminal button has got these vesicles and the mitochondria, and this vesicle store acetyl neurotransmitter acetylcholine in it. So from where is this acetylcholine coming from? It is synthesized by the mitochondria. Okay, you can see the mitochondria also there. This mitochondria, acetylcholine is synthesized by the mitochondria, and within the mitochondria it is synthesized and it is stored in the vesicles. So for the storage, for the synthesis of acetylcholine, what all is needed? You need acetyl coenzyme A, which is present in the mitochondria. You need glucose. You need ATP. All these are present in the mitochondria itself. The only thing required for the synthesis of acetylcholine is choline. Choline is not in the mitochondria, but it comes from the smooth endoplasmic reticulum. As you know, fatty acids and steroids are all synthesized in the smooth endoplasmic reticulum. This choline part is coming from the smooth endoplasmic reticulum. Rest are all synthesized by the mitochondria itself, except choline. So choline is coming from smooth ER, smooth endoplasmic reticulum. So looking at this diagram, now you also concentrate where it says this presynaptic membrane has got voltage gated calcium channels. Voltage gated, this word is also again important. Presynaptic membrane has got voltage gated calcium channels. And one more thing, this postsynaptic membrane is thrown into folds. As you can all see, it is thrown into folds. This is called, this postsynaptic membrane has got receptors. Those receptors are called acetylcholine nicotinic receptors or nicotinic acetylcholine receptors. The one in this blue ones, on the blue colored thing which is thrown into folds, this thrown into folds is called palisades. Why should it be thrown into folds? Because it can increase the surface area so that neurotransmitter can act. That is why it is thrown in folds, these junctional folds. Everywhere this receptors will be present. If it's a straight line, this many receptors would not have been present because it is thrown in folds. At the junctional folds, on the top, bottom, everywhere these receptors are present. So it has got receptors called nicotinic acetylcholine receptors. These receptors are ligand gated receptors, ligand gated, whereas calcium receptors are voltage gated calcium receptors, whereas these are called ligand gated receptors. So these receptors open up only when acetylcholine come and attaches to it. I'll tell you about that later. Okay, now next slide. Most of this is only through slides, so you pay attention. Nothing is written here. You pay attention to the diagrams, so it will be easy for you. Now, when the nerve impulse, now the blue arrow, it shows when the nerve impulse from the neuron, nerve is coming into the terminal button. Now, impulse action potential has come from the nerve and it has come into the terminal button. This yellow one is the terminal button. When it comes into the terminal button, the calcium gated, voltage gated calcium channels open up and increase in the permeability of calcium will be there. So this and lot of calcium comes from the ECF into these terminal buttons. So now the terminal buttons has got lot of calcium in it. When this terminal buttons increases, this calcium content in this terminal buttons is increased, what will it do? These vesicles will increase and exocytosis of this ACH will be done. How will it be done? This vesicle slowly come when lot of inflow of calcium is there. This vesicle slowly come and get attached to this presynaptic membrane. You can see there, they slowly get attached and they release the acetylcholine. This acetylcholine is diffused into the synaptic cleft. When there is lot of calcium entering the terminal button, these synaptic vesicles will come and fuse with this presynaptic membrane and they empty their contents into the synaptic cleft. This here you need to use the word exocytosis. Entry of calcium will trigger the exocytosis of the vesicles. This word is very important. Here you need to use the word exocytosis. Opposite of exocytosis is endocytosis. Here exocytosis is happening and the calcium is diffused into the synaptic cleft. Now what will happen to the calcium? So here you should remember voltage gated calcium channels and exocytosis. Next slide. So what will happen? Now this calcium has come into the synaptic cleft. In the synaptic cleft, acetylcholine has come into the synaptic cleft. This acetylcholine will come and bind to this receptors, nicotinic ACH receptors. It comes and binds to this nicotinic ACH receptors. Why are they called nicotinic ACH receptors? Because they are stimulated by nicotine and acetylcholine. That is why the name is nicotine acetylcholine receptors, and they are inhibited by curare. So they are stimulated by acetylcholine and nicotine and inhibited by curare. Okay. Now this acetylcholine comes and gets binded to these receptors present on the postsynaptic membrane. So what is how are these receptors? Again, I'll come back to this page. Look at these receptors. These receptors are present through and through. They penetrate through and through the whole of the cell membrane. These receptors are there. These receptors are nothing but it's a protein complex. This protein complex has got 5 subunits. 2 are alpha, 1 is beta, 1 is delta and 1 is gamma. So, but these receptors open up when these 2 acetylcholine molecules get attached to this 2 alpha subunit protein. Only alpha units. See, now that has opened up. These ligands will come and bind to this. Bind to 2 alpha acetylcholine protein unit. Then only they open up. See, then only this acetyl-gated channels open up. This is the protein complex and it gets opened up when acetylcholine molecules come and get attached to this 2 alpha subunit proteins. Then only they get opened up. In the next diagram, you can see when they get opened up, when they are getting attached, this is closed. So when they get opened up, sodium ions will flow in. So look at the third diagram. They got opened up and sodium ions, those ligands came and got exactly fitted into this alpha subunits. Then the channel is opened up and sodium is flowing into it. This is how these receptors look like. So now what happened? Now I told you when the action potential has reached the terminal. When action potential reaches the terminal, voltage gated calcium channels open up and increased permeability of calcium is there. Now the calcium has entered the terminal button. When this calcium has entered the terminal button, there will be exocytosis of the acetylcholine. So look at the first, number 1, action potential has reached the terminal. Second one is voltage gated calcium channels have opened up. Look at the third one, calcium is entering into the axon terminal. Look at the fourth one, neurotransmitter. Here the neurotransmitter acetylcholine is released and diffuses into the cleft. Look at the fifth point, neurotransmitter is coming and binding to this postsynaptic receptors. Postsynaptic membrane, I told you the receptors are present. Neurotransmitter has come and is binding onto the postsynaptic receptor. And the sixth point is this acetylcholine will stay in the synaptic cleft for less than 1 millisecond. You can ask me why. So the neurotransmitter is present for the long time. As long as the neurotransmitter is present, it will come and attach to this acetylcholine receptors. The channel will be opened up and lot of sodium will be flowing in. If that lot of sodium is flowing in, there will be only muscle will be in contraction all the time, like tetanus. So that acetylcholine has to be removed. So then only next phase can start. I'll use those words in the next page. That is why it is very important for the acetylcholine to be destroyed. It will be destroyed within 1 millisecond. Now, I told you about these receptors. Receptors, they are present. It penetrates throughout the membrane, postsynaptic membrane. Throughout the membrane, it has got five protein subunits. They are called nicotine acetylcholine receptors, and they come and bind there. Then only this channel is opened up. Now what will happen? We'll continue from there. Now axon terminal synapses as acetylcholine has been liberated. It has come and stuck to this receptors on the postsynaptic membrane. So when this acetyl, when this gate is open, lot of sodium ions from the ECF will enter. So actually what is the resting membrane potential of the skeletal muscle membrane of this membrane is around minus 90 MV. When lot of this sodium ions enter inside the muscle fiber, there will be positive potential change. Lot of positive ions are coming inside. So there will be positive potential change leading to depolarization of the muscle membrane. So it leads to depolarization of the muscle membrane. When the depolarization is occurring, it will give rise to end plate potential. So here one more word is important, depolarization, because lot of positive ions are entering into the muscle fiber from the ECF. Sodium ions are entering into the muscle fiber. So there will be depolarization and this will lead to end plate potential. So depolarization, what is end plate potential? It is non-propagative. It is only limited locally. And when this depolarization from minus 90, it summates and it will reach the threshold level of minus 60, it will fire an action potential. Then only it will fire an action potential. Action potential will go on both. I said this neuromuscular junction is at the center of the muscle fiber. So this action potential will spread in both the directions. And then the muscle will contract, that excitation contraction coupling. So that you will know about it later. So here local depolarization will be there at the end plate potential, only local, because lot of positive ions are entering into the muscle fiber. So from the negative, slowly positive ions are entering. That is why there is local depolarization. Whenever it is occurring only at this motor end plate, it is called end plate potential. But when it reaches a threshold stimuli, increases in the spike potential, then only it can fire an action potential. When it is spreading all over the membrane, when it is spreading all over the membrane, what will happen? More and more sodium channels will be opening up and lot of sodium ions will be coming out. So a lot of sodium ions will be entering inside the muscle fiber. Then only it can fire an action potential. If you see here, it is the local. Here first diagram is local depolarization is taking place. That is the end plate potential. And slowly lot of sodium ions are entering into the muscle fiber. Then it will lead to action potential. So when will it lead to action potential? So initially at the end plate, we can see sodium is entering in and potassium is going out. But when it reaches the action potential, we can see only the sodium ions entering in and potassium channel has closed. Then only depolarization will occur. Then only this depolarization will occur. So generation and propagation of the action potential closed. Then again, if you want the repolarization to happen, what should happen? Sodium channel should close and potassium channel should open. Then only repolarization will happen. So when it is very important for the muscle from the depolarization state to enter the repolarization state. As long as the acetylcholine is there and the acetylcholine gates are opened, lot of sodium will be coming in. So only depolarization will be occurring. So acetylcholine should be destroyed from the synaptic cleft. So acetylcholinesterase enzyme will destroy the synaptic cleft. Then only repolarization will occur, and it can receive the next impulse. So repolarization is very important. So as long as acetylcholine is there, only depolarization will be occurring. That is why it should get destroyed for the repolarization to occur and to get the next impulse. Otherwise, only re-excitation of the muscle will be happening, and body will be in contraction like tetanus. So that is why. So when will this membrane is around minus 90 MV, yes, resting membrane potential is around minus 90 MV. When this minus 90 MV will become to minus 60 MV, because it can become, because lot of sodium ions are opening up and lot of potential ions, cations are entering it. And at the same time, it is preventing the potassium ions to go out. Then only lot of positive potential change is there. Then only end plate potential will give rise to action potential. Same thing. So local potential. So minus 90, this is all local potential. When it reaches about 60, minus 60, then only action potential is fired. So for the depolarization to happen, sodium channel should open up. For the repolarization to happen, sodium channel should close and potassium channel should have open. So acetylcholine, if it is destroyed, only repolarization can occur. Removal of acetylcholine by cholinesterase. I told you acetylcholine should be removed from the synaptic cleft. It can be removed within 1 millisecond by two ways. Mostly destroyed by acetylcholinesterase in the synaptic cleft. In the synaptic cleft, acetylcholinesterase is there, I said. So this acetylcholinesterase will destroy this acetylcholine, and it will it will break down, hydrolyze into acetyl and choline. Acetyl is acetate. Acetate is again for your Krebs cycle, cellular respiration. Krebs cycle, it will be metabolized and to give out energy. And this, what is happening to the choline? Choline will be again reuptake by the vesicles. Choline is not getting wasted, it will be reuptake by the vesicles. Again by the vesicles it is taken up. So acetyl, it is hydrolyzing into acetate and choline. Choline is again taken actively by the vesicles, whereas acetate is again it gets metabolized to give out energy. So little bit of acetylcholine, whatever is remaining, also diffuses out of the synaptic space and it is no longer available for action. So little bit acetylcholine is destroyed by, most of it is destroyed by acetylcholinesterase, but whatever is remaining also diffuses out of the synaptic space and it is no longer available for action. So that much time the acetylcholine is present in the synaptic cleft is enough for the to bring about the end plate potential. For the muscle to contract also, that much of acetylcholine which is remaining for 1 millisecond, less than 1 millisecond is enough. So what is the clinical importance? Why should we block this neuromuscular junction? Neuromuscular junction should be blocked for surgical operations. If you want to do some surgical operation, they block by giving some drugs there, so the field will be very relaxed. Then the surgeon can operate easily. So if the muscle is contracting, it's very difficult. So we have to, surgical operations, the neuromuscular junction is blocked, and also while giving the for psychotic patients to give ECT, electroconvulsive treatment, also the neuromuscular junction should be blocked. Then only the muscles will be relaxed and they can go for this ECT. What are the same thing? Just see what are the steps in neuromuscular junction. So first thing, action potential is reaching the presynaptic terminal of the neuromuscular junction. The change in voltage causes the opening of the voltage-gated calcium channels, which causes exocytosis of the ACH containing secretory vesicles. The neurotransmitter ACH is secreted into the, it is coming into the synaptic cleft. ACH crosses the synaptic cleft and it is a ligand-gated ACH channel, and these acetylcholine gated channels are opened up, and there it will allow the sodium to move into the inside of the muscle fiber. As long as the ACH is present in the synaptic cleft, it keeps activating the ACH channel, which remains open. We do not want it. That is why ACH should be destroyed after its work is done. Okay, the influx of sodium into the muscle lead to the initiation of the end plate potential. You should remember, end plate potential is non-propagative. It is only local. It is only local. So when it summates to that from -90, when it comes to -60, then only action potential. All the end plate potentials will not give rise to action potential. Only when it comes up to -60, then only action potential. Here one more thing, whenever we are relaxing also, little quanta of ACH is always released into the synaptic cleft. Little bit of, whenever we are releasing also, same thing will happen, and little bit of ACH is always getting released. And this is called miniature end plate potential. Miniature end plate potential, because that will give rise only to 0.5 MV in amplitude waves. So that is called miniature. It's a weak end plate potential. When we are resting also, some ACH is coming into the synaptic cleft, but it will give rise to miniature end plate potential because it is a weak end plate potential. Next, if you can answer all this, I found this on the net. Well, if you can answer all this, that means you have understood neuromuscular junction. If it was a Google Meet, I would have asked you. So now, an action potential is entering the presynaptic terminal. Voltage gated channels open, and what ions will enter the presynaptic terminal? Calcium ions enter the presynaptic terminal, and one and is there, but it's only one dash. Calcium ions enter the presynaptic terminal. Dash ions cause to fuse. Okay, calcium ions cause synaptic vesicles to fuse with the presynaptic membrane. Synaptic vesicles will to fuse with the presynaptic membrane. It's all happening in the terminal button. Dash is liberated into the synaptic cleft. Acetylcholine is liberated into the synaptic cleft. The neurotransmitter reacts with dash on the muscle membrane. The neurotransmitter is reacting with what? These receptors, ligand-gated nicotinic acetylcholine receptors on the muscle membrane. Channel open up and the muscle membrane is depolarized. The muscle membrane is depolarized. This produces an end plate potential in the muscle membrane. End plate potential. In other side also it is there, some arrow. The neurotransmitter is broken down by dash in the synaptic cleft, by acetylcholinesterase in the synaptic cleft, and dash is taken up into the presynaptic cell. Choline is taken up into the presynaptic cell. So this will complete your neuromuscular junction. So here the important points what you should know are coming from the beginning. Whenever this could be an essay also. So what are the important things are the naked nerve endings. This axon terminals have got knobs. Those are called synaptic knobs or terminal buttons or end feet. Some books say end feet. Don't get confused. They are called end feet also. That is important there. And where does it, this is the motor end plate word you should use. So it is making this terminal buttons are making a close and intensive contact with the muscle sarcoplasm. That is called the motor end plate. This motor end plate, each motor end plate has got one nerve fiber, and this is present in the center of the muscle fiber. so that impulses can be spread evenly in both the directions. Okay. Then the words you should use is voltage gated calcium channels, exocytosis, and ligand gated nicotinic ACH receptors. What is presynaptic membrane you should know. What is postsynaptic membrane you should know. Synaptic cleft. The synaptic cleft is rich in ECF. You should know that. And also there acetylcholinesterase is there, and what is the function of that acetylcholinesterase you should know. And how is this ACH synthesized? It is synthesized by the mitochondria, and within the mitochondria, what are required for the synthesis are all present in the mitochondria itself except the choline you should know. And then these are the steps. What will happen when action potential comes? When will this calcium gate comes? Exocytosis, and this acetylcholine is coming and binding with the receptors you should know. Then how this acetylcholine is removed you should know. And what is the structure of this nicotine ACH receptors? Only when these two acetylcholine molecules bind with the 2 alpha subunit protein complex, then only this channel will open up. And this channel, as I said, it's all negative channel. Negative. Mouth of the channel is all negative because this resting membrane potential is around minus 90 MV. So everything is negative. Mouth of the channel is negative. And that is why it will pull the positive ions inside very quickly. And as you all know, ECF has got lot of sodium ions. So ECF has got the rich ion in the ECF is the sodium ion. So sodium ions will enter quickly and it will repel the chloride ions because chloride ions are negative. So it will repel the negative ions. Only the positive ions will enter, and at the same time it will prevent the potassium ions to go out. That is why positive potential change is happening. That is why it is moving from minus 90 towards the minus 60. That you should know. And here all the steps. First, you also should say what is end plate potential. Directly it will not bring about the action potential. When lot of these gates are opened up, then only it will bring about the action potential. So local depolarization is the end plate potential, which is not propagative. It is only there, but it will slowly depolarize the membrane adjacent to it. That will depolarize the membrane adjacent to it. So when it is depolarizing, more and more of sodium ions is entering. Lot of positive ions are entering, and at the same time it will be it will inhibit the potassium ions to go out. So it is slowly the membrane is getting depolarized and it is spreading, bringing about the action potential. So this is the same diagram, and how acetylcholinesterase is destroyed I told you, and what is the clinical importance of this, and I also told you the steps. From end plate potential it can go to the action potential, but you should use the first word is end plate potential. Okay. And small quiz on the neuromuscular junction. If you can do this quiz, you can write this neuromuscular junction. Okay, hope you understood, and thank you.